In this video, all students will be able to make an exponential equation for a word problem. So this is where exponential equations become really powerful. We've been practicing them, but now you get to see how useful they are. Okay, they're actually very useful, and so today you will be making your equations for a word problem. Number 1, Kayla has $60 in a savings account. The interest rate is 5%, compounded annually. That means that each year, whatever is in her savings account, she gets 5% more of it. Okay, so it's like a reward that a bank gives you for saving money. Okay, let X represent the number of years Kayla keeps her money at the bank, and Y represent her total amount of money. So, we're going to make a table of values. You cannot have negative years, so we're going to start with 0. 0 year, 1 year, 2 year, 3 year, 4 years. Okay, just a short table. Okay, we're going to find out how much money she has after each year. Well, what about at the very beginning, after 0 years? How much money does she have? She has $60. She's starting with $60. Now, at the end of that year, she's going to get that 5% interest, like a reward, okay? So 5% interest. So to find out how much money she has, we're going to take this 60 that she started with, and we're going to multiply it by 1.05. Okay, the reason why it's 1.05 is because she's keeping 100% of her money, but she's also getting 5%. So if she's keeping 100% and getting another 5%, that decimal is 1.05. So 60 times 1.05 is 63. She made $3. She got 3 bonus dollars. Okay? So, how much money will she have after 2 years? Okay, so she started with 60. After the first year, she had we'd multiply it 1.05 to find out she had $63. We know that's 63, and we have to multiply it by to get 5% more again. Okay, so if I do 60 times 1.05 for the first year, times another 1.05 for the second year, I get $66.15. All right, how much money does she have after 3 years? After 3 years. Well, I could take the 66.15 and multiply it by 1.05, and I would get 69.46. Just a side note, if you did this on a calculator, you would have gotten 69.4575. But since it's money, we have to round it to nearest hundredth. So that 7 kicks the 5 up to a 6. Just a reminder about rounding to hundredths. Okay, so we got that by using the 60 she started with, multiplying it for 5% for the first year, also finding out the interest for the second year, and finding out the interest for the third year. Okay, so for the fourth year, we're going to do it again. We're going to multiply that by 1.05 again. 1.05 again. And we get 72.93. Okay, so now we need to focus on this notice anything column. So what do you notice? Well, started with $60, then we had to multiply it times 1.05 to find out how much she has after the first year. Okay, then we had to multiply that by 1.05 again to find out what she had during the second year, or at the end of the second year. Then we multiply that again by 1.05 to find out what she had at the end of the third year. And, sorry, this is actually, there's another 1.05 on here. You probably caught my mistake already. And then for the fourth year, we had to multiply that by 1.05 again. So, what do you notice? What do you notice as the pattern continues? Started with 60. Then we had to multiply it by 1.05 one time. So we took the 60 and we multiplied it by 1.05 just one time. The next one we had to multiply 60 by 1.05 two times. Then we had 60 times 1.05 three times. And then lastly, we had 60 times 1.05 four times. So what pattern do we see? Each year, you multiply by 1.05 again. So, just to be clear, to find out how much she had after the first year, you multiply it one time. Let me use a different color, make sure you can see what I'm doing here. I feel like I'm jumping around too much. Okay, so after the first year, you multiplied it by 1.05 one time. For the second year, you started with the 60, but you had to multiply it two times. For the third year, you had to multiply it three times. Do you see how the year and the exponent match? So let's see, what could this be? If I wanted to find out her total money, what did I start with every time? I started with 60, and I multiplied that by 1.05, but the number of times I multiply it changes based on the number of years, so that's going to be our exponent. So y equals 60 times 1.05 to the x. Okay, so on the next slide, we're going to talk about what each part represents. Okay, so we just had this equation. I'm just going to write it right above here, just so we can revisit it. Okay, so let's talk about each point, or each part of this. This was the output. Okay, this multiplier right here, look back at what it represented in our equation a second ago. It was the 60. And in that word problem, what did the 60 represent? It was the starting amount. It was the starting amount. Now, I also want to remind you that the starting amount is also your y-intercept. That multiplier that's out front, it always represents the y-intercept. Now, the base, that's going to be the ratio. So in this case, it was 1.05. So that's the one that repeats. The one that each time it's going to have to get multiplied by that thing over and over again. And then x is the number of terms. So that could be the number of years, or the number of days, or the number of, it depends on the oops, I didn't mean to write years, I meant to write terms. Depends on the word problem, what it actually represents. Go ahead and pause this video and get this all labeled on your paper. For your homework, you're going to try number 2 to the best of your ability, and you're going to bring your work to class tomorrow, and we will begin by reviewing your work. Thanks, Honey Bunnies!